Assalamu alaikum to all participants. Are you listen me? Are you listen me, sir?
Yes, your voice is clear and your screen is shared.
Thank you, sir. Sir, my topic of presentation is dynamics and control of a plant-herbivore models incorporating Allee's effects. First of all, sir, I'm very thankful to all participants and especially, sir, you to give me time for presentations and explore my views in front of all participants. My name is Sir Muhammad Qurban and my research supervisor is Dr. Abdul Khalik sir. My outline of presentation, sir, historical background, introduction to dynamical systems, stability of discrete dynamical system, Neimark-Sacker, state feedback controls, numeric simulations, and conclusions. First of all, sir, I share my abstract. In this presentation, we develop in this presentation, sir, I describe about the fixed point of dynamical systems and that fixed points and investigates the bifurcations type, especially in Neimark-Sackers at unique fixed point. And then I put up some techniques of chaos control, such of which is state feedback control to control to control the chaotic behaviors of the system. And finally, sir, simulation, numeric simulations and phase portraits and dynamical diagrams. And after all, I put the conclusion of this presentation. First of all, the historical background. In the 20th century, sir, Alfred J. Lotka in 1925, the American biophysicist Alfred J. Lotka published his work on the elements of physical biology, where he introduced the mathematical models to describe the dynamics of biological models. In this model, sir, he describes about the dynamical models of continuous models, sir. Vito Volterra, after all, 1926, he also described the same relationship between predator and prey models. After all, sir, Lotka Volterra model is generate. This is a totally continuous models. Continuous models means differentials models are said to be continuous models. Here, sir, X is represented by pre-populations and Y is represented by the predator populations. Here, pre is such like, sir, that's effects by the predator is called pre-population. Alpha is the neutral natural growth rate of pre in the absence of predator. Beta rate at which predator reduce the pre-populations. Gamma natural death rate of predators in the absence of pre. And delta rate at which predator increased by consuming prey. So this is techniques I present to convert continuous model to discontinuous or discrete model, sir. There is a Euler forward model methods in which, sir, we put x n plus 1 minus xn over delta t instead of dy over dt, yeah, dx over dt, sir. And delta y n plus 1 minus yn over delta t instead of, sir, dy over dt. Then, sir, here we putting delta t equal to 0, and after some calculations, sir, this is discrete version of the same continuous model xn plus 1 equal xn bracket 1 plus alpha minus beta yn plus 1 equal yn 1 plus delta xn minus gamma. So basically, dynamical system is a concept in mathematics used to describe a system that evolves over time. Means, sir, the dynamical system changing with respect to time according to a specific set of rules under some certain rules that defines that change the behavior of the system with respect to time. These rules are usually defined by differential equations. Difference equations are other mathematical formulations that describe how the state of the function change. This is a graph of continuous versus discrete models. This is shown the line. This is straight and continuous. There is no any intervals. This is continuous value from begin to end. And dotted line shows the discrete models. This is interval values. After certain intervals, the values repeated. Continuous dynamical system, these systems evolve over continuous time and are typically described by ordinary differential equations, ODEs. This is represented by ODEs or partial differential equation, PDEs. Example of such motion of plants. The motion of plants revolve in a certain time continuously, no any breaks. The flow of fluids, just such like flow of fluids is also flow continuously. And population dynamics, population change in population, sir, with respect to time. This is a graph of flow of water, the flow of fluid. This is a graph shows the discrete dynamical models. These systems evolve in discrete steps, often described by difference equations or iterated map. Example include population models in ecology where generations do not overlap, and economic models with periodic updates. Means after some periods they change their behavior, yeah, repeat their behavior. Means there is a discrete interval of time. Means there is no continuity in the models. This is also graph shows that the population of fin whales along y-axis and ears along x-axis. This is year 0. This is the change in populations with respect to time. This is interval change, not a continuity. Understanding dynamical system. Dynamical system involve analyzing their behavior over time, study the stability of their equilibrium points, equilibria, identifying bifurcations, and something dealing with chaos and complex behavior. The tools and techniques used in this field include linear algebra, calculus, numerical simulation, and qualitative analysis. This is plant herbivore model. We can say host parasite model. Here is the knowledge, yeah, the difference, yeah, the interaction between prey and predator. The plant herbivore model is an extension of predator prey model to describe the interaction between plant populations. This is producer and herbivore population. This is primary consumer. This consume the plants that destroy the plants. These models capture the enhance of how herbivore consume plant and how these interactions affect their respective population dynamics. This is a graph between grapes and grapes borer. I also the research work, my research work is also represents or shown about the relationship between grapes and grape borer. Is a parasite on the grapes leaves or grapes roots or grape stems and destroy the grapes populations or grapes growth. Stability of discrete model. First of all, we discuss about the stability of discrete dynamical models. Here, this is my model to this is my published model in Halion journals recently 2024. Here X is represented by the plant population, Y represented by the herbivore populations, A is the intrinsic growth rate, B is the efficiency of converting consumed plant into herbivore offspring, C the rate at which herbivore consume plant. The C is my parameters. I discuss about C. I discuss the relationship of variation in C and their results. M is the Allee effect constant. A is dx m1. This is term xn over xn plus 1. This is says to be Allee effect terms. This is we put this effects on pre-population. Xn is a pre-population. Xn plus 1 is a factor that divides pre-population. Here M such that depends on the Allee effects. Means M, if we increase the value of M, the Allee population, Allee effect is strong. If we decrease the value of M, the Allee effects is decrease gradually. Here we find the fixed point or equilibrium point of the system. This is method in discrete dynamics. We put x equal to functions and y equal to y functions, or x equal to x equations or y equal to y equations, and after some calculation with Mathematica and simple calculation, we find the three fixed points. This is C1, 0, 0. This is trivial point. C2, A minus 1 over B, comma 0. C3, this is a unique points. C2 is a boundary points. Definition here, we put a lemma or definition about to verify or the method to verify the stability of equations of an equation of stability or eigenvalues. This is put up on the eigenvalues. The value of eigenvalue change the stability of system. Alpha, zeta 1 and zeta 2 are two values of any characteristics equations. If zeta 1 more less than 1 and zeta 2 more also less than 1, this the system is sync at this point. If zeta 1 greater than 1 or zeta 2 absolute value of zeta 2 greater than 1, then the point Mn is a source and locally unstable. If zeta 1 absolute value of zeta 1 less than 1 and absolute value of zeta 2 greater than 1 or absolute value of zeta 1 greater than 1 and absolute value of zeta 2 less than 1. Thus, the point is the sync means source point. Or absolute is equal to 1, then there is known hyperbolic system. This is the Jacobian of the system. Jacobian, we can find a method. This is curly x curly x curly y over curly y. After calculation, we find the Jacobian. We find the Jacobian of the dynamical system at their stable points are fixed point or equilibrium points. This is 0, 0 is also equilibrium point. We put x 0 and y also 0. This is the change in Jacobian matrix. And we put the
Muhammad
other
Furqan,
points.
just 2 minutes
That,
remaining. Last 2 minutes.
yes, sir.
Wind up your talk.
Yes, sir. Yes, sir. This is, sir, Jacobian points on the absolute value. We find the lemmas on the C2 value. C2 values are agaram. For example, here is the Jacobian. This is zeta 1 and this is zeta 2. Absolute value zeta 1 less than 1 and absolute value zeta 2 less than 1. Then we conclude our result on stability. And that's a change if we just like zeta 1 or less greater than 1 and zeta 2 absolute value zeta 2 greater than 1, then our result is stable. Sorry, local source point. If zeta 1 less than 1 and zeta 2 greater than 1, or zeta 1 greater than 1 or zeta 2 less than 1, then this is saddle point. Or zeta 1 or zeta 2 equal to 1, then this is non-hyperbolic points. Such same this behavior we put on our unique points our C3, and here we the stability of this unique points we find through jury method. Jury method we define trace the characteristics of this Jacobian matrix. This is zeta say this is trace minus trace of zeta plus determinant. This is the characteristics of our characteristic equation against C3. If after some calculation we put tau 1 is this is tau 1 greater than 0 or tau 1 minus greater than 0 and tau 0 less than 1. This is our stable point. If tau 1 greater than 0, this is our saddle point. Source point if great equal to if tau 0 equal to 1, then this is a known hyperbolic point. And result is shown this lemma. We find Neimark-Sacker bifurcations. There is no enough time to present our presentation in detail, so I present our presentation in minor time or in not in detailed version. This is the result. This is our parameter, defined parameters. Here C is our parameter, and we take this parameter from the non-hyperbolic points here. Because bifurcation, we define bifurcation on bifurcation is a qualitative behavior of the system, and this is we define bifurcation at such point where the system change their behavior. This is system from stable to unstable or unstable to stable. This is result after some mathematical calculations in Mathematica and other softwares. L, this is our real number. This is zeta 1, zeta 2 are the eigenvalues. Omega 1, omega 02. This is also a set of values we find up to put the normal form of bifurcation theory. Here
Mr. Kobat,
theorem.
you have last minute.
Yes, sir. Yes, sir. Here is all. After some, sir, I'm put state feedback control, and there is no time to describe this. And just I put on the numeric simulations. I find the table here for the value of C. C value is greater than, and the value of L is minus. The value of L not equal to 0. The value of L may be minus or may be positive. The minus describe the subscriptical Neimark-Sacker, and the plus value describe the supercritical Neimark bifurcations. In this section about the numeric simulations, this is our graph, Neimark-Sacker graph. This is X means prey and Y means predators. Prey means plants and predator means plant wars. Yeah, grapes wars. The stability of the system disturbed as 0.66. Here the distance same as 0.66 along x-axis and 0.66 same as if we put the values along y-axis. Same as all other graph of the system by the change of initial values of the system. This is graph of stability. The system here is stable along x and it is stable along y and same x and same y and if we put the value of c less than 0.622, the system, our system remains stable. If we put the value of c greater than 0.66 or point greater than means from the interval 0 to 3, thus begins unstable and there is a same characteristics, the same behavior of the system unstability stable. This is the region where the system is stable. This region we find after applying the state feedback control. The conclusion of our thesis, sorry, of our presentation, the model accounts for the dynamics between plants and herbivore, incorporating the Allee effect, which signifies a positive relationship between individual fitness and population size when population is are sparse. The symbols X and Y and denote the plants and herbivore population correspondingly comprehensive and managing the dynamics of the herbivore models incorporating early effects, implications for ecological conservation and management, implementing chaos control method shows potential in maintaining population stability and safeguarding ecosystem against potential chaotic patterns. That's how the bibliography I used in this presentation. Thank you for listening and please put up any questions
Thank you, Mr.
related
Kurban.
to my
Thank you.
presentation. Yes, sir.
So let's move to
Yes, sir.
questions, answer. So
Yes.
please raise your hand,
Yes.
attendees, participant, if you have any question. So if no question, Mr. Kurban, yes, answer Abbas, please. Mr. Answer, you can ask.
Yes,
Yes.
sir. Mr. Kurban, is there any other type of bifurcation exists in your proposed system as you discuss two-dimensional system? Please explain.
Yes. Yes. Also, transcritical bifurcation also exists in my system and in Halion publications. I put these papers that describe transcritical bifurcation, pre-doubling bifurcation. There is no enough time to describe such bifurcation in here. Also exists such any type of such a type of bifurcation instead of Neimark-Sacker, in spite of Neimark-Sacker.
Uh, is there any specific method on which we can say that this is the bifurcation exists in our system? Is there any criteria to check
Yes, yes,
the
yes,
existence of
yes. There is
bifurcation? Please.
yes, yes. There is no normal form theory we use to define the criteria where the which type of population exists in our system. Or we see about the chaotic behavior of indicators or numerical diagrams that such type of bifurcation exist in our system. Or we put up on the that behaviors or that criteria on our fixed points that describes about the numerous cycles or bit doubling or transcritical or much types of bifurcation exist here.
Thank you. Thank you.
Thank you very much, Mr. Kurban. So now we have a break and we will resume again from 2:30. Thank you very
Thank
much,
you,
all
sir.